Hi Geometry, this is page 8 of our packet and it's solving radical functions. Those are functions that involve a square root or in this case also a cubed root. So to solve an equation that has a square root or square root, we square both sides. To solve an equation with a cubed root or cube root, we cube both sides of the equation. So I'm going to use these side areas in our packet to take notes. So the first set of notes is going to be on the left side of your packet. So let's do those now. Example 2. Okay, stop it. So this will be the notes down the left side of our packet page. And this is going to be on solving square roots. So let's begin with an example problem. We're going to do 3 times the square root of x plus 2 equals 15. So my step 1 in these types of problems is to isolate the radical. So in this case, I want to get the square root of x plus 2 all by itself. And I've got a 3 times it. So I'm going to divide both sides of my equation by a 3. And now once I've done that, you'll notice that I have my square root of x plus 2 isolated, and it's equal to 5. So once you have it isolated, step 2 is to raise both sides to a power to cancel the radical. So in this case, it's a square root, and I want to cancel the square root. So I'm going to raise it to the power of 2. If I square a square root, then they cancel, and in this case, I get my x plus 2 on the left side. The radical was canceled with the squaring, and on the right side, I get 25. So then step 3 is simply to solve. So in this case, I'm going to subtract 2 from both sides, and I get x equals 23. So now you can check your answer simply by plugging in the 23 and seeing if you get the same thing on both sides. So if I wanted to check my answer, I could look at what is 3 times the square root of 23 plus 2. Is that equal to the other side, which is 15? Well, 23 plus 2 is 25, and the square root of 25 is 5, and 3 times 5 is 15. I do indeed get 15 equals 15. You do need to consider checking your answers because you're going to have next year in Math 3 Enhanced sometimes something called an extraneous solution. And that will be a solution that doesn't really make your original equation true. It made your equation after you squared both sides true, but it doesn't make the original equation true. That will not happen to you on our homework this year on this worksheet. But keep in mind, you do want to check your answers to check for extraneous solutions. Let's keep going. This is still down the left side of our paper. I hope you have room for our example 2 on the left side of our paper. So the next example I want to look at, example 2, we'll call this one example 1, is the square root of 6x minus the square root of 2x plus 2 equals 0. So anytime you see something like this set up with both square roots on one side, you want to make your math much easier by simply moving one radical to the other side. So I'm going to add this square root of 2x plus 2. I'm going to add it over to the other side. And now what I have is the square root of 6x equals the square root of 2x plus 2. This is a much easier problem algebraically than what I had before. When I square both sides now, basically they're just going to cancel. And so when I square both sides, my square roots just cancel. And on the left side, I simply have a 6x. And on the right side, I have 2x plus 2. So now I'm ready for step 3. This is when I solve it. So I'm going to subtract 2x from both sides and get 4x equals 2. I'm now going to divide both sides by 4, and I end up with x equals 1/2 as my answer. When I go to check that answer into the original, I have the square root of 6 times 1/2, which is the square root of 3, minus, and then I have 2 times 1/2, which is 1, plus 2, which is another square root of 3. And the square root of 3 minus the square root of 3 does indeed equal 0. So I know that I've got the right answer, and it's not extraneous because it makes my original equation true. So how about we'll write some notes on the right side of our paper. So on the right side of our paper, let's solve some cubed roots. So these are notes going down the right side of our paper, and this is where we're going to solve a couple cubed roots. So example 3 for us is going to be 3 times. So now when I write a cubed root, I write a little 3 in the index spot. So I know this is a cubed root. This is not a square root. And we're going to say it's the cubed root of x plus 5 equals 12. So my steps are the same as we wrote on the left side. The first thing I'm going to do is isolate my radical. That means that I need to get rid of the times 3. So I'm going to divide both sides by 3. And I'm left with the cubed root of x plus 5 on the left side equals 4. So now step 2, I'm going to raise both sides to the power of an exponent that cancels my radical. So if I want to cancel the cubed root of 3, I'm going to cube both sides. So the cubed root and the cube cancels, and I just get x plus 5 on the left. And on the right side, 4 cubed would be 4 times 4 times 4, or 64. So I'm ready for step 3, which is to solve. I'm going to subtract 5 from both sides. Looks like I get x equals 59. You can plug this in to make sure that you get the same answer. I think if you plug x equals 59 in, we get, let me get a different color here. We get 3 times the cubed root of 59 plus 5. We're trying to see if that equals 12 to make sure I did my work right. So 59 plus 5 is 64. The cubed root of 64 is 4. 4 times 4 times 4 is 64. If you don't know that, then you need to use the cubed root button on your calculator. And 3 times 4 is indeed 12. So I know that my answer is fine. How about example 4? Staying on the right side of my notes, just put example 4 underneath example 3. Let's do the cubed root of x plus 4 equals the cubed root of 3x minus 10. So this problem happens to have a cubed root on both sides, and so to simplify it, I'm simply going to start with the second step, where I'm going to raise both sides to the power of 3. That 3 exponent of 3 is going to cancel my cubed root of 3. And on the left side, I get x plus 4. On the right side, I get 3x minus 10. And now I just need to solve this. I'm going to move my integers to the right. So I'm going to add 10 over and get 14. Move my integers to the left. So I'm going to add 10 to both sides and get 14 on the left. I'm then going to subtract x from both sides and get 2x on the right. Finally, I'm going to divide both sides by 2, and I'm getting x equals 7 for my answer. If I want to check that to see if I did it right, I see on the left side, I would get 7 plus 4, the cubed root of 11. And what do I get on the left side? So that would be 3 times 7, or 21 minus 10, which is also 11. So it looks like I'm getting the cubed root 11 on both sides. I could do it on my calculator. It's some decimal. I don't know what it is. But the point is that it would be the same answer. So I did do my work correctly, and my answer is 7. Thank you very much.